Welcome to ClickMyProject.com. Now we're going to discuss about the project multi-source transfer learning via multi-kernel support vector machine plus for B-mode ultrasound-based computer-aided diagnosis of liver cancers. Now we're going to discuss about the abstract of the process. In recent years, several computer-aided diagnosis system emerged for the diagnosis of thyroid glands disorders using the ultrasound imaging techniques. These systems, based on machine learning algorithms and as well as the deep learning algorithms, may offer a second opinion to radiologists by evaluating the malignancy risk of thyroid tissues, thus increase the overall diagnosis accuracy of the ultrasound imaging. Although current computer-aided diagnosis systems exhibit the promising results, their using in the clinical practice is limited. One of the most main limitation is that the majority of them use the direction department features. Our intention has to the using the all the department should be in the medical field can use this process to detect whether the liver is affected by the diseases or not. Hence, in this process, we are using the liver ultrasound images to detect whether the liver is affected by the disease or not. If the liver is affected by the disease, the classification result should generate the report it is the affected by the diseases. Here we are followed the steps like major three steps, that is the feature extraction, classification and performance. Using these three steps, we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The project consists of the modules like input, pre-process, feature extraction, classification and performance. Now we get into the flow diagram. At first, the input is taken from the dataset. The dataset having the several images of liver which having both the affected one and a normal one. After getting the input from the dataset, we just move on to the pre-processing. In this pre-processing, we have three stages of pre-processor, that is the image resize, grayscale conversion, noise filtering. In the image resize, the image is resized into a particular size of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. If the input image is an RGB band, means it will be converted into one grayscale form. So why we are go for the grayscale conversion is it will easy to extract the features from the image. After the grayscale conversion, we just move to the third stage of the pre-processing, that is the noise filtering. In this noise filtering, actually we have to remove the noise present in the image. If the input image consists of the noises, it should be removed by using the filtering method. After the pre-processing, the third stage of the project is the feature extraction. In this feature extraction, we are hybriding the two kinds of features. One is the GLCM and another one is the LBP. We are hybriding these two features together to generate a new features to extract the features from the image. After the feature extraction, as usual, we go for the classification. In this classification step, we have two kinds of classifier which will be hybrid together. That is, the one thing is the multi-SVM, then the another one is the KNN classifier. We are hybriding these two classifiers to generate the new classification report. The classification report will gives the whether the input is normal or affected. Then the final stage of the process is the performance estimation. In this performance estimation, we have performance parameters like accuracy, sensitivity, specificity, positive predictive value and negative predictive value. Based on these parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Now the user interface was open. In that user interface, you can see the several push buttons in the right side for the controlling actions, and then the several axes and tables in the left side for the display purpose. Now I have to click the button input image. After clicking the button input image, you have to select the image from the dataset. After the selection of the input image from the dataset, the corresponding image is shown in the axis 1 with the title input image. After the selection of the input, we just move on to the second step of the process, that is the pre-processing. In this pre-processing, the image will be split it into three type of pre-processes, that is the noise filtering, resize and grayscale conversion. First of all, if the noise is present in the image, it should be removed in the filtering step. If the noise is not present in the image will remains the same. After the removal of noise in the image, we just move on to the next stage of the pre-processing, that is the resize. The image should be resized into a size of 256 x 256. Whatever the size of the input image, it should be resized into a 256. After the image resize, the grayscale conversion should be done to convert the image into a grayscale form. If it is an RGB image, it will be converted into a grayscale image, or else the image will remains the same. After the completion of the pre-processing, we just move to the next step of the process, that is the feature extraction. In this feature extraction, we have two kinds of features is there. One is the LBP, then the another one is the GLCM. First of all, I just explain the concept of the GLCM. First of all, the GLCM will be extracted from the image. The GLCM having the features like autocorrelation, contrast, energy, entropy, dissimilarity, like that. We have several kinds of features is there. After extracting the GLCM features, we just move on to the local binary pattern, that is the LBP. So in this LBP, first of all, it will generate the LBP image like this. After the generation of the LBP like this, then extracting the features from that LBP image like this. This is the feature value from the LBP. Once the feature extraction is completed, we just move to the next stage of the process, that is the classification. In this classification step, it will decide the input image having the tumorous or non-tumorous. If it is having the tumorous, means the classification result should shows the image as an tumor image, or else it will shows the normal image. This is the region affected by the tumor. Now the tumor region is indicated like this. After the classification, we just move to the last stage of the project, that is the performance estimation. In this performance estimation, we have three kinds of performance parameters, that is the accuracy, sensitivity and specificity. The values of that accuracy, sensitivity and specificity are plotted like this. Thanks for watching this video.